Assalamu alaikum, grade 6. Welcome again to the physics session. Today, inshallah, we're gonna start lesson number 3 in this is chapter number 3. And actually, we have still one lesson to finish our curriculum in this is quarter. And the title for today that's talking about the inclined planes and levers. And that's examples of simple machines. And as you know, we're talking about that understanding the machines and how the work of machines in the last lesson. So today we come talking about the inclined planes and levers. And the big questions here in our lesson today. Number one, how do inclined planes work? How do inclined planes work, and actually what is the meaning of inclined planes? And how are levers classified in three classes? So now you can go into the opener of our lesson today. It's a machine or not? In this picture, which objects in this photo are machines? Actually, here we talking about the different kinds of machines have motors, like the car and motorbike. But this is example of simple machine, the motorbike and other vehicles containing many simple machines. But there are dozens of machines in this photo, just like this is slope of flat slope. That's meaning inclined plane, and not just ones with motors. So inclined planes, that slope of this flat that's helping to work or to do work either. And this is the direction of force, like this is man riding the motorbike up, this is slope. Now you can go into the points. Number one in our lesson today, how do inclined planes work? Actually, what's the meaning of inclined planes, or especially simple machine? A simple machine is most basic device for making work easier, and that we talking about in last lesson about the function of machines. And the simple machine here including three kinds of machines or three examples. Number one, the inclined planes and the wedge and screw. We taking each one in this is lesson inshallah, and this is our simple machine that form the inclined plane family. And this is all, this is examples, three examples, that's inclined planes, wedge, screw, that's from the inclined plane family. Actually, what's the meaning of inclined plane? Inclined plane, just like this is lecture, that's made up of flat, sloped surface, and that allows you to exert your input force like this over a large distance. So that allows you to exert your input force like this in this direction by large distance. And the mechanical advantage, now do you remember the mechanical advantage we talking about in the last lesson? And that's talking about the relation between or ratio between the input force and output force of inclined planes. Here calculated the mechanical advantage by dividing the length of slope, and this is inclined plane, and the height. Dividing the length of inclined and the height of this is slope. Now all of you now understand the meaning of simple machines and the inclined plane, the symbol number one or example number one for the inclined plane family. Number two, wedge. Actually, wedge, any devices that's made up of two parts. Number one, thin, and number two, it width. So wedge is devices that think in at one end and the towards to a thing each at the other end. So think and thin. And the wedge is a machine that moves, uh, moves, not like the inclined planes. And instead of moving an object along the inclined planes, you move the inclined planes itself, but the but here we moving the inclined planes, not standard. So the ideal mechanical advantage here of the wedge to make larger output force calculated by dividing of wedge, the length of wedge, and the width, and the longer and thinner a wedge is that have greater mechanical advantage. Actually, here this is video describe or make imagination about the wedge. Wedge is that device that make you to separate any object. Have two ends. Number one thin and number two thick. So have one side thin and one side thick. And the input force in this direction and output force in this is different direction. And you can see here the output force and the input force, and there's the relation between them. The mechanical advantage here can be calculated by the length of the wedge and the thing, how width the wedge. Now all of you understand the example number 2 for simple machines and depending of the inclined planes family, the wedge, any device helping you to separate something to two pieces. And this is the kind of example here, and here the input force and the outward force here, and that's made up of thin and thin sides. Now you can go to the next example. Next example here, screw. Actually, we using this device in our life many times. A screw is like an inclined plane. That's family inclined plane, and actually wrapped around a cylinder. So that's wrapped around the cylinder. So we have here cylinder, and wrapped around it, that's the screw. And actually the threads of screw acts like an inclined plane. This is threads here, just like this thread, and we can make imagination for the threads like that. And this is video that's talking about how that screw works. And actually that acts like the inclined plane and increasing the distance over which you exert the input force. So if you put the input force, that's increasing the distance. And the ideal mechanical advantage for screw here is the length of the stretched out threads like this, divided by the length of screw. So here we have the length of thread stretched out, and this is equal amount 24 centimeters, and here the length of screw 3 centimeters. So when I divided this is number, or the length of threads stretched out, and by all the distance of the screw, we can get the ideal mechanical advantage. And the mechanical advantage here in the screw is greater if the threads are closer together. So if each threads closer together, that make the mechanical advantage higher or greater. And we can see here how the screw work. So screw here have a length and have length any length about the threads. Now all of you understand the three examples of in inclined planes family, beginning inclined planes and wedge and screw. Now we can go into the next step or next point, and actually this is the end of this is lesson. How are levers classified? Actually, what's the meaning of lever in the beginning? Actually, a lever is a rigid bar or harder bar that is free to rotate on a fixed point, and this is fixed point we can call it the fulcrum. Fulcrum is the fixed point here or measuring point here in this is lever. Again, lever is rigid bar or harder bar that is free to rotate on a fixed point. We can call it fulcrum. Seesaw, actually seesaw is the play game that is a type of lever or that very important example for lever. Seesaw is type of lever in which the fulcrum is located halfway, in the halfway between the input force and output force. Again, levers that's made up of ridge, bar, and fixed point we can call it fulcrum, and the different or main example here is a seesaw. That's the fixed point here or fulcrum that's halfway between the input force and output force. So when affected here in this side, we get the input force and we have the output force in this direction. Mechanical advantage. The ideal mechanical advantage of lever is calculated by using this as formula. That's different from the inclined planes. Ideal mechanical advantage here we can calculate it by dividing the distance from fulcrum to input force by the distance from the fulcrum to output force. Again, the ideal mechanical advantage we can calculate it here in the lever by dividing the distance from the fulcrum to input, the distance between the fulcrum to input force, and the distance by the distance between or from the fulcrum to the output. Now we have three classes of levers. First and second and third classes of levers, and now we can going to talk about this is classified of levers. Number one, first class of levers change the direction of the input force, increasing the force or distance. So here the located of fulcrum between the input and output force. So the fulcrum here that's located between the input and output force, and this is the first class of lever. And we here input in this is direction input force, and we here in another side the different direction of output force. So here what's happening here, the lever changed the direction. So you can observe here the direction of input and the opposite direction of output, and we can call this effort and load, and actually change the direction of input and increasing the force or distance. Now you can any place here between the input and output force you can put the fulcrum. So we can put the fulcrum between our fixed point between the output and input force any position here, and we can call it first class of levers. And this is example for a seesaw. But now we can watching with this is video to make some examples of levers and explain the classified of levers.
The pivot point on a pair of scissors is a fulcrum. The fulcrum on a bottle opener centers the force applied to it. Fulcrums play an important role in the actions of a lever. On a seesaw, the fulcrum is the anchor point that does not move. An oar is a lever. The fulcrum is the point at which the oar is sitting on the oar lock. Without a fulcrum, the lever has nothing to support or balance it, so no work can be done.
Excellent. So this is video explain how much the importance of fulcrum fixed point in the levers, and that's point not moving, and we can measuring the three classes of levers by this is point fulcrum. So number one or first class in this is lever made up of fulcrum between the input and output force. But number two or second class of levers increasing force. How increasing force? You can watch this is videos about how the second class of levers. Here, not change of direction happen of the input force, but the output force here is between the fulcrum and the input force. So if we put this is loud or this is weight as output force or giving up, this is weight between the fulcrum and the force. So here the fulcrum not finds or take place between the output force and input force, but here take place in the opposite side of the input force, and between the fulcrum and the in force or input force found the output force. Again, in the simple word, the second class levers that's talking about that some flat or rigid flats that give or that we can put it in one side in the fulcrum in another side to affecting with the input force, and the output force founding between or take place between the fulcrum and input force. And this is example for the when something or when pick up some weights with using some flats just like this, and put the output force here between the input force and fulcrum. So again, second class levers that's talking about the fulcrum take place in the side and the input in another side, and between them found the output force or to make this work together. This is weight, just the load. Now I hope you understand the second class of levers. Now we can talking about the last point here in our lesson and the third class of levers that increasing the distance, but don't change. But here the input force is found between the fulcrum and the input force and output force actually. So third class levers that's describing the three classes of the levers, and that's describing not change any direction of input but change direction of the output. So here the input force found or take place in the middle between the fulcrum and the output force. Now, this is the end of our lesson. Today we're talking about the inclined planes and the three kinds or examples of inclined planes family and the levers and how we can classify the levers to three classified. Number one, that's talking about the middle between the fulcrum founding in between the input force and output force. Number two, the fulcrum take place in the input in another place or another side and the output force between them. Here, the input force between the fulcrum and the output force. I hope you understand our lesson today, and actually we have one lesson to finish our curriculum in our quarter, inshallah. And I hope you understand the lesson for today. Study well and answer the worksheet. Any question you can ask me in WhatsApp. And thank you for listening. Goodbye.